Howdy, this is Mr. Justice. In this video, I'm going to show you how you can process your raw data from the soil salinization seed germination lab. Recall prior to this, we measured the lengths of the roots of each of those beans, and then they ended up in this spreadsheet here. And I've kind of color-coded it here to make it a little bit easier to process. Note that, for example, I've already sorted all of our responses based off of the concentration of salt. Right? And so take a look, 0%. There were 3 people that inputted 0% concentration, that seeds that were germinated in 0% salt, basically water, and then 0.25% and 0.5, 1%, 1.5, 2%, and 3%, all from those different petri dishes. And then, take a look. These are all of the lengths of each of the seeds here. And what we want to do is determine the average of each of these seeds here, the lengths of all of the seeds per concentration. So take a look here, right? I've color coded 0% as being red. So all of these red lines here represent the beans that were germinated in 0% salt solution. Likewise, 0.25% salt solution is all orange, and you can kind of see the general trend there. All right, so how do we figure out the average length of the root? Note that the first one has already been done for us. So actually, if you click on this cell, just click on it, you see up here that there is an equation right here. And this equation will calculate the average of all of the lengths in, well, take a look, G4. So that's right here. That's the cell here. Right, take a look at the way that the spreadsheet is set up. So notice that the letters are at the top. So this column is G, and then note that all of these rows all have numbers on it. So G4 goes from here, there's a colon, and then to L6. So basically, those. And so how do you figure out the average then, right? Take a look. So we're going to, whenever we start to create an equation here in a spreadsheet, we're always going to start with the equal sign. So let's do the 0.25% one together. So start with an equal sign. Type in equal. We want to find the average, and so this one's easy. We're going to type in the word average. And then what we want to do is, well, we're going to find the average of all of the numbers here in light orange, right? So that's really going to go from, let's see, G7 to L12. So the way that we write that, we've got to put this into parentheses. So we're going to find the average of basically that very large rectangle. That goes from G7. Let's create our first parentheses from G7 to colon L12 and end parentheses. And when you click enter, the spreadsheet will automatically calculate that average for you. Let's do another one here in the yellow. All right, remember when we start up an equation, go ahead and click equal sign, average. And then this one is going to go from, well, let's see, G13 to L16, all of the yellow right there. So let's type that in. Remember, in parentheses, we'll go from G13 colon to L16. End colon, push enter, and the spreadsheet will automatically calculate the average of all of those numbers that I've determined right here in this yellow area, right? Let's take a look at the next one, right? 1% seem to be pretty popular here, so we're going to average all of these numbers together within this square, right? So we're going to go from G17 to L22. So equal sign average, G17 to colon L22 end parentheses and push enter. Now, if you make a mistake, sometimes we'll click outside of that box and all of a sudden the spreadsheet will start adding extra cells to our equation, which we don't want. So remember that you can always access that equation that we typed in here into this green box. It will be found right here. And so we can actually type it up here too if we wanted to, right? If we made a mistake and we needed to change one of these numbers here, let's say it was L23, which it isn't, but right, we can change any of these numbers as well. But I want to make sure that I am doing exactly that yellow, green box, and that's going to go from G17 to L22. So just make sure. And then once you're finished, again, push enter and it calculates for you. I'm going to take a second here and finish up the rest of the averages. And I'll meet you back here so that we can input this into our data table and create a graph from it, okay? See you in a minute. All right, so we finished all of the average lengths here. And what I've done here on the spreadsheet is I've helped you guys out with a data table. Take a look here, the data table for average length of root, and the concentration is located here. It's data table number 1. So what we'll want to do now is well, we're going to put each of these average lengths into that Y column on our data table. 0%, right? Remember that I've color coded these here. So 0% is 4.11. How about we go to the nearest 100th, since that image J that we used to calculate each of these numbers went to 100th in terms of its accuracy. Take a look now. We've got 3.36. We've got 1.89, and let's just keep going. 0.96, it looks like. 0.58, and let's see what 2% is. Looks like it's 0.25, and then this one's easy, 0, because nothing grew at 3% salt solution. All right, so how do we make a chart out of this? Take a look. What we'll do is use this data table. It's actually pretty simple, and turn this into a nice scatter plot. So what we do is just select the 2 columns. And what I want to do is make sure that I select the concentrate, like the titles, right, of each of these columns, concentration of NaCl, average length of the root, and then each of those numbers there. And what we'll do is go up to insert. This is so great, right? Gone are the days of having to use rulers and graph paper. This is going to do everything for us. So click on chart. And hey, it's built it perfectly for us. But take a look. What I want to do here is, customize this a little bit here. So let's go ahead and over here at the chart editor. By the way, if you lose the chart editor, let's say that it closes out. Where did I go? Come over here to your graph again and see those little 3 dots. This is how we can get back to edit chart. Get that back up. All right, and we'll go over to customize. Now, listen, if it doesn't look like a scatter plot, which I want it to do, it should look like this. You can change the change the type of chart right over here. I like scatter plot because what we'll do is click on customize and then click on series. And what we can actually do is add in a trend line. Take a look. Right, so where am I? I'm on customize series. Scroll down, click on trend line, and the computer will interpolate the averages between all of those data points and create a nice linear line for us. In addition, we can also label this line right here with an equation. And what it will do is it will determine the y equals mx plus b, this format of the slope of a linear line. And so, think about this. Y equals mx plus b. The m in front of the x is actually the slope. And if you take a look here, the slope is negative 132. Right away, we've got a metric that we can use when we start to make claims. This is a negative slope. And since it's a negative slope, we're going to be able to say that this is a negative relationship here between the independent and the dependent variables, right? As concentration increases, the average length of each of those roots seems to decrease. And how do I know that? Well, because this slope right here is a negative number. Pretty wild. This r squared value here, if you want, you could add this on there here too. This is also a statistical measure that tells us how close our data points are to the trend line. And the higher that r squared number towards 100% or 1, the more confident we can be in the numbers. And this is a pretty high value right here. All right, so take a look what you can do here too. This is pretty cool. When we need to create a data table and a graph in, let's say, our lab handout, take a look at what you can do. Take a look. You can select this. Actually, I'm going to select data table 1, and what I'll do is copy, and then we'll come over to our doc right here, right? Question 6 asks you to create a labeled data table, and all I need to do now is, since I copied it, is paste it. And do I want to link to the spreadsheet? Yes. Pretty cool. All right, so we've got our first data table here. And before we move on to the second data table and second graph, I want to point out where we're going to put that graph. Take a look. Question 8 says, construct 2 graphs. Now I made a quick change here in our lab. So the first graph is going to use the concentration of NaCl and the average length of the root, the graph that we just did. So that's going to be for A. If we come up here to our spreadsheet, hey, this graph has already been done for us. And so let's go ahead and copy it. Let's see, can I copy it? Nope. I'm going to have to go up to edit and copy. And then watch this, the magic of spreadsheets. This is pretty cool. We'll paste it directly there, and we want to link it to the spreadsheet in case anything changes. We can actually update it right there. And of course, if you need to, you can go ahead and kind of resize it right there. And note that I've got this gorgeous graph. I've got my r squared value, and then also that slope number here too that can be used in claims. All right, so let's go back to the other spreadsheet over here, and I'll move some of this stuff out of the way. All right, the good news is that with the more difficult one has been finished for us. Let's go ahead and do this one now, students. This is going to be the percent mortality. The percent mortality. So how do we figure that out? Well, if you recall, we determined the number of alive germinated seeds and we compared them to the dead seeds. Now, between periods 5 and 6, not all of the seeds in each of those concentrations acted the same way. And so what I've already done here in this column P is I've given us the average mortality of each of them. So, 0%, the average mortality was 0 because none of the seeds died. On average, about 1.33 of the seeds died or didn't make it in concentration 0.25%. Take a look, about 3.2 seeds on average didn't make it here in 0.5 concentration. And so you can see each of those in that column. But what we want to do is determine the percent mortality. So if we had 6 seeds, let's think about this, and 0 of the 6 seeds didn't die, what's the percent mortality? Well, 0 over 6. Multiply it by 100 to move the decimal point over, and you get 0%. Now, how can we have our spreadsheet do the math for us? Take a look. Start with the equal sign. We're going to build out a nice equation here. So equals 0 over 6, or the number in this cell, P6, divided by the total number of seeds, 6. And when we push enter, we get ourselves a nice response, 0%. All right, take a look at the next one. Let's do this one together. We'll start out with an equal sign, equals the number in P12, divided by the total number of seeds, 6. And when I push enter, whoa, look at this. I just made a mistake. Notice what I did. put in the wrong number, right? I put in 912 instead of P12. And so if I ever make a mistake, I'll just mouse over and click on the cell, and then I can come up and actually manipulate the number up here, this equation. So I'll change that into P12. My goodness, what a mistake. There you go. All right, and recall this is not quite percentages yet, and so we'll add that percent sign. Notice what I just did. I took that number and I added a percent and called it a day. Let's do the next one. The number in P16 divided by 6. Click on this cell and let's convert it to percentages if it's not already done. Click percent and it will convert that into a percent pretty readily. I'm just going to do the rest of them for us here. And of course, if you want to skip ahead to the next part, you may do so. All right, so now that we have determined the percent mortality of each of the seed groups for concentration, we're going to put those numbers here into this data table. So let's see, 0%. The next one down is 22.22%. Next one is 53.33%, 47.22, 38.89. Let's see the next one, 72.22, and then 100%. All right, so let's turn this into a scatter plot. So we're going to go ahead and select all of the data, including the titles here of each of these columns. Come up to Insert, Chart, and hey, there we go. We've automatically created our nice looking graph here. And just like last time, let's go ahead and click on Customize, and we'll add a linear trend line. That trend line can also use the equation here. Note the slope here is a positive number, 27.6, right? Y equals mx plus b is the equation, the general equation for determining the slope here. And since that 27.6, that's a positive slope number, we can talk about how this is a positive relationship between the two variables here. But we can also use this equation here to determine a value. Now there's a value that we're going to learn about later on in class called LD50, or lethal dose 50. And what that is the lethal dose of some contaminant like salt, or some chemical like a magnesium sulfate, or really anything that can cause harm and decrease biodiversity. In this case, we're talking about salt. So LD50 refers to the lethal dose at which 50% of the organisms die. 50% of the organisms is the LD50, the lethal dose. And so what concentration of NaCl would that be? Well, what we can do is take this value here, this y equals mx plus b, and plug in some numbers, right? If we know that y is 50%, then we can calculate x, that concentration of the chemical of salt that will kill off 50% of our beans. And so allow me to pull up my other camera here so that we can do this math together. All right, so let's do this, right? Think about y equals mx plus b. We're curious to know at what point 50% of the organisms will be will die. So what concentration will 50% of our population die off if exposed to what concentration of salt? So let's go back to that equation. 27.6x plus 0.152. All right, so 50% we're going to solve for x. X is our concentration of salt. And so now it's just a matter of doing some order of operations, right? Okay, let's do it. 50 minus 0.152, 49.848 is equal to 27.6. We'll get x by itself. X is equal to, divided by 27.6, is 1.8%. So our lethal dose of concentration of salt that will kill off about 50% of our green beans, it seems to be about 1.8%. All right, so I hope that you guys got something out of this. Just real quick, I wanted to point out that you can indeed copy and paste these data tables into our assignment. And I just wanted to show you how easy that is to do. Pretty cool. And we'll come back and grab that other graph. Yeah, the mortality one, good. Copy and paste. All right, and there you have it. That's how you do the data analysis for our soil salinization lab. Let me know if you have any questions. Talk to you guys soon.